Namaskar. In the previous few videos, we have been discussing about the topic exact differential equations. We have seen the definition of an exact differential equation. Then we have seen the necessary and sufficient condition for exactness. That is the condition which will tell you whether the given ODE is exact or not. And finally, we have seen cases of non-exact ODE and integrating factors which upon multiplying with a non-exact ODE transfers that non-exact ODE into an exact ODE. So let us start today's video by recapping the previous topics and then we shall move on to the new topic of finding integrating factors. So let us start today's video. Now suppose an ODE is given in this differential form m dx plus n dy equal to 0 where m and n are functions of x and y. When shall I tell this ODE to be exact? If this m dx and n dy can be written in the form d of some function, then we shall tell this ODE to be exact. Now let us suppose that the given ODE m dx plus n dy equal to 0 is exact. That is m dx plus n dy can be written in the form d of some function. Then how will you test whether this given ODE is exact or not? That is, what is the necessary and sufficient condition? The condition was del m del y equal to del n del x. That is, whenever this problem will be given, any ODE is given, then you have to first test whether del m del y is becoming equal to del n del x or not. If it is becoming equal, then the given ODE is exact. If not, then the given ODE is not exact. This was the condition for testing whether the given ODE is exact or not. Next, suppose that the given ODE m dx plus n dy equal to 0 is not exact. But anyhow, if you can find a function u such that which upon multiplied with m dx plus n dy equal to 0 makes this total ODE to be exact, then u will be called the integrating factor of this ODE. This was the definition of integrating factor. So what was integrating factor? The function which when multiplied to an non-exact ODE transfers the non-exact ODE into an exact ODE is called an integrating factor. Now the question is, how will you find the integrating factors? Let us start today's video. To begin with the motive of today's discussion, let us start with this total differential d of x by y. Now what is d of x by y? If you compute this, it will become y square y dx minus x dy. So this is equal to 1 by y dx, or rather let us write y by y square dx minus x by y square dy. Okay, now suppose the equation is given this equal to 0. Let us now backtrack of what we have done. Suppose this equation is given, forget about these two lines, okay, and so if this is given, then this is m and minus x by y square is n. Now suppose you are asked whether this ODE is exact or not. You can easily tell, okay, since this line, this m dx plus n dy can be written as d of x by y, so this given ODE is exact. Now what happens if I remove this y square from here? So now the equation is simply y dx minus x dy equal to 0. You can test this. This ODE will be a non-exact ODE. The testing criteria is del m del y equal to del n del x. Okay, this will not be equal. Del m del y will not be equal to del n del x. So this given ODE is non-exact. Now we have seen that if we multiply this given ODE with 1 by y square, this ODE becomes exact because this now can be written as d of x by y. Now let us rethink what we have done. This ODE was given y dx minus x dy equal to 0. We tested that this ODE is non-exact. Then we have multiplied this ODE with 1 by y square on both sides and transformed this non-exact ODE into an exact ODE. My question is, how did I understand that I have to multiply this ODE with 1 by y square? Because by inspection, by seeing this, we have understood that if we multiply this with 1 by y square, then more or less this can be converted to d of x by y. But the serious question is, for this problem, I have understood that I have to multiply this ODE with 1 by y square. What for an arbitrary problem? Suppose any problem is given which is non-exact, how will you understand what to multiply with the non-exact ODE so that the non-exact ODE becomes exact? By every time through method of inspection we cannot tell. So there must be some rule or some trick by which we can understand that this will be the integrating factor. In today's video, we are going to see some tricks or some rules by which you can tell if this is the given non-exact ODE, then this will be the integrating factor. So let us see those rules. Now there are 5 to 6 rules for finding integrating factors. Throughout our discussion, we shall consider the non-exact ODE to be of the form m dx plus n dy equal to 0, where m and n are functions of x and y. So this is the first rule. What does this rule say? If m and n are homogeneous functions of same degree, then the integrating factor is 1 by mx plus ny, provided mx plus ny is non-zero. Because if it becomes equal to 0, then this becomes undefined. Anything divided by 0 is undefined. Now firstly the question is, how will you understand whether m and n are homogeneous of same degree? See, for this example, what is m x to the power 4 plus y to the power 4, and what is n minus xy cube? First do del m del y. What is del m del y? So with respect to y, you have to consider x to be constant, so it is 4y cube, and then del n del x, it is minus y cube. So these two are unequal. If these two are unequal, then the given ODE is non-exact. Now the problem begins to find the integrating factor. Okay. Now this rule will be applicable to this problem. Why? See, firstly, these two are homogeneous. Why? Because how will you test whether these two are homogeneous? Just look at the degrees of x and y. See over here, what is the degree of x? 4. Degree of y? 4. Same. So this is homogeneous. So this is how will you test whether m and n are homogeneous or not. You have to see the degrees of the terms. If the degrees of each term are equal, then this is homogeneous. Now how will you test of same degree? See, degree of x 4, that is power of x is 4, power of y is 4, power of this term x power is 1, y's power is 3, 3 plus 1 4. So if the terms are multiplied, you have to add up the integral powers. See, 1 plus 3 4, over here also 4 and 4. Hence these two functions are m and n are homogeneous functions of same degree. So I hope you understood how to test whether these two are homogeneous or not. Now see, if this would have been cube, then no, it is not homogeneous. Okay, because the powers of x and y are different. Now again, Suppose this is 4 and over here it is x square y cube. This is homogeneous, but these two are not of homogeneous of same degree, because see, even if these two are homogeneous of degree 4 of power 4, but over here the total addition of the powers is 2 plus 3 5. It is not matching with the number 4. Hence, this also will not be homogeneous of same degree. Since in this problem we have the power of x as 1 and y is cube. So 1 plus 3 4, over here also 4 and 4. Hence, these two are homogeneous of same degree. Now that was the first criteria. Second criteria, you have to check whether mx plus ny is non-zero or not. Let us check. If m is x to the power x4 plus y to the power 4 and n is minus xy cube, then what is mx plus ny? Mx plus ny, m into x. So this term into x. So x to the power 5 plus x y to the power 4 plus n into y. N into y. So minus x y to the power 4. So this two gets cancelled out, equal to x to the power 5, which is non-zero. Okay. So you can tell now that all the criterias for this integrating factor are satisfied. The m and n over here are homogeneous of same degree and mx plus ny is non-zero. Hence, what is the integrating factor? 1 by mx plus ny. Now, since this is the first example of today's video, I will solve this problem completely for you. For the next few examples, I'll just find out the integrating factors. You will solve those problems by yourself and let me know the solution in the comment section. Let us solve this problem. Now, the integrating factor of this problem was 1 by x to the power 5. You can skip this video backwards and see how did we find out that integrating factor. So, if we multiply 1 by x to the power 5 with this ODE, then this ODE becomes exact. We can tell this is exact because now we have multiplied the integrating factor with this ODE. Now, how will we solve this ODE? Let us apply the shortcut method. Okay. If you have missed that video of shortcut method, the link will be given in the comment section, in the description box. You can click that link and see that video. Now, how will you apply the shortcut method? The solution is you just have to integrate the m part. What is the m part? X to the power 4 plus y to the power 4 by x to the power 5, because you have to multiply this 1 by x to the power 5 throughout. So the m part is this dx plus you have to integrate the n part, removing the terms which contains x. Okay. Over here n has only one term, minus xy cube divided by x to the power 5. So the n part is minus xy cube by x to the power 5. So if you cancel out this x, the x in the term remains. The rule was you cannot keep any term of n which contains x. Since n has only one term over here and that too contains x, so you cannot keep any term of n over here. Simply this equal to c will be the solution. You have to just integrate this one, or integrating x to the power 4 by x to the power, that is 1 by x dx plus y to the power 4 by x to the power 5 dx equal to c, or 1 by x dx, that is log x, or more precisely you can write ln x because the base is e over here, plus y to the power 4, because you are integrating this one with respect to x, so y to the power 4 will be treated as a constant, into x to the power minus 5, that is x to the power minus 5 plus 1 divided by minus 5 plus 1, that is, so over here it will be minus of minus 5 plus 1, that is minus 4 over here. So it will be y to the power 4 by 4 x to the power 4 equal to c. So this is the solution. So the steps were, first check whether the given ODE is exact or not using that criteria, del m del y equal to del n del x or not, it carries 2 marks. Then try to find out the integrating factor. For this problem, the criteria was that m and n are homogeneous of same degree. So the integrating factor was 1 by mx plus ny, provided mx plus ny should be non-zero. Then the normal procedure, that is the shortcut method, integrate m, whatever you have in m with respect to x, plus integrate n, removing the terms which contains x. Over here, one term of n was there and that too it contained x. So we had to remove all the terms of n. Equal to c will be the solution, and you have to just integrate this one, you will get the solution. So this is how you will solve a non-exact ODE problem. As I told before, in the next few examples, I'll just give you a demonstration of how to find out the next type of integrating factors, and the solution of the entire problem you have to find out and you have to let me know in the comment section. So let us move on to the next few examples. Now let us see this rule. It says that if m dx plus n dy can be expressed in the form y into some function of xy. Okay, now it is not x comma y, it is x into y. So this function is not a double variable function, it is a single variable function, and that variable will be in the form of compact form of a product of x and y into dx plus x into some function, another function of xy dy. Then the integrating factor is 1 by mx minus ny, provided mx minus ny should be non-zero. Let us see a demo of this rule in this problem. Now suppose this problem is given, you have to solve this problem. In examination, this problem is given, you have to solve this problem. The first thing is that you have to write what is m and n of this problem. The m is this part, x square y cube plus xy square plus y, and n is this part, x cube y square minus x square y plus x. Then what you have to do? You have to test whether this given ODE is exact or non-exact. Now sometimes in the problem when it is given, we always tend to think, okay, the problem is given, the problem will definitely be non-exact and we have to find out the integrating factor. No, first you have to test whether actually the given ODE is non-exact or not, because who knows, suppose the given ODE is exact and you are busy finding out the integrating factor, which is useless. So firstly you have to test whether the given ODE is exact or not using that criteria, del m del y equal to del n del x or not. You can test over here, it will not be equal. Okay, this problem is non-exact. So let us just skip to the next part, that is finding out the integrating factor. Now see, if you look back to the previous rule, that rule said that you have to test, you have to see if m and n are homogeneous of same degree or not, because in the problem, in the examination, what it will be given to you, the rule which you have to apply will not be told. You have to judge by seeing the problem. So let us not eliminate the previous rule also. First check whether these two given ODE are homogeneous or not. See, over here, the adding of the powers 2 plus 3, that is 5. In the next term, the addition of the powers 1 plus 2, it is 3. So it is differing, it is not same. So each term, the powers of total addition of the powers of each term are not equal. Hence, m and n, these two are not homogeneous. Forget about same degree, not homogeneous. So that rule will not be applicable to this problem. Now let us see if this rule is applicable to this problem or not. See, in the first term, that is the term of n, you can take y common. If you take y common, what you have? X square y square plus xy plus 1 dx plus, from here if you take x common, what you have? X square y square minus xy plus 1 dy equal to 0. So if you take y common, the terms which are inside, see, these terms can be written as xy whole square plus xy to the power 1 plus xy to the power 0. Over here also, if you take x common, it can be written as xy whole square minus xy plus xy whole to the power 0. So if you take xy as a single variable, you can tell this is a function of xy, because over here taking xy as a single variable, you can write this one as xy whole square plus xy plus xy whole to the power 0. Similarly for here also, same thing. Now see, I'll show you the other way also. Suppose anyhow you had y cube over here. Suppose if you had y cube over here, you will not be able to write xy total whole to the power something over here, since the powers of x and y are different over here. In this problem, luckily the powers of x and y in each term, after taking out y common, you are seeing the powers of x and y are equal. So you can combine x and y whole to the power something plus xy whole to the power 0, like that. So you can tell this as y into some function of xy dx plus x into another function of xy dy equal to 0. So see, m dx plus n dy can be written in the form y into some function of xy dx plus x into some function of xy dy equal to 0. It is matching with this criteria. Now you have to check whether mx minus ny is non-zero or not. See, this is m and this is n. So mx minus ny, what is that? This one into x. So x cube y cube plus x square y square plus xy minus ny, so minus of n into y, x cube y cube plus x square y square minus xy. So sorry, minus x cube y cube plus x cube y cube minus xy plus xy. So 2x square y square remains, and that is non-zero. So mx minus ny is also non-zero over here. Hence you can tell the integrating factor of this problem is 1 by mx minus ny, that is 2x square y square. And after that you have to multiply this integrating factor over here into the original problem and then solve the problem by using the shortcut method, which I had shown before also. Okay, so this is how you will find the integrating factor For this type of problem, you have to check whether m dx plus n dy can be written in this form or not. I discussed with you that how to find out that this, after taking y common, it is a function of xy only. After taking out x common, it is a function of xy only. How you will test that? How you see that? I have discussed that. Okay. And then finally, you have to check whether mx minus ny is non-zero or not. If these two criteria are satisfied, then 1 by mx minus ny is the integrating factor. Okay. Now this third rule is a bit different from the previous two. It says that if 1 by n into del m del y minus del n del x equal to some function of x only, then integrating factor is e to the power px dx, where px is that function which we got from this expression 1 by n del m del y minus del n del x. Now the previous two examples, it actually told you to test the forms of m dx plus n dy. Over here, it has nothing to do with the form of m dx plus n dy as a whole, but you have to test whether 1 by n del m del y minus del n del x is a function of x only or not. So let us see this example. Suppose this problem is given in your examination. How will you approach this problem? Let us see by which mindset, by which logic shall we approach this problem. I have told you before also, depending upon the rules, you have to find out the integrating factors. But in the examination, which rule you have to apply will not be told before. So by seeing the problem, you have to eliminate each rule one by one, and then slowly you have to find out which rule will be applicable to this problem. See, if this problem is given, the first rule which we have seen today, it told that you have to first test whether m and n are homogeneous of same degree or not. What is homogeneous? We told you that the powers, that the sum of the powers of each term will be equal. See over here, the first term x y square, power of x is 1, power of y is 2. So 1 plus 2, 3. Second term, you cannot find out the degree because it is a transcendental function. Hence, the first rule is eliminated. It is not a homogeneous case. For the second one, let us take y common from here. Can you take y common? You cannot take y common because over here in this term you have y, in this term you don't have any y. See, in the second rule, it was y common into some function of xy dx. Okay, so that rule also got eliminated. Let us see whether this rule is applicable or not. For that, first you have to test whether del m del y is becoming equal to del n del x or not. So let us find out del m del y. What is del m del y? This is m. So with respect to y, it will be, for the first term, it will be 2xy. The next term does not contain any term of y, so it will be 0, because when you are differentiating with respect to y, you have to take x as constant. Now, what is del n del x over here? It is minus 2xy. Now see, if we do this, so these two are unequal, obviously it is non-exact. Now what is 1 by n del m del y minus del n del x? Let us see. What is 1 by n? That is 1 by minus x square y into del m del y minus del n del x. So 2xy minus of minus 2xy, that is 2xy plus 4xy plus 2xy, that is 4xy. So y and y gets cancelled, x and x get cancelled. It is 4 minus of 4 by x. That is a function of x only. That was the criteria. Now, if it is a function of x only, what is the integrating factor? So, the integrating factor will be, as per the rule, e to the power integration of px. What is px? Px is this over here, the function of x only, that is minus 4 by x dx, that is equal to e to the power minus 4 ln x, which is equal to e to the power ln x to the power minus 4, which is equal to x to the power minus 4, that is 1 by x to the power 4. So 1 by x to the power 4 is the integrating factor for this problem. Again, how will you further solve this problem? You have to multiply this integrating factor in the original equation, and then you have to proceed with the shortcut method to solve this problem. So this is how you will get the integrating factor for this class of problem, where you have to test whether 1 by n del m del y minus del n del x is becoming equal to a function of x only. See, for this problem, if any term of y would have been existent over here, then you couldn't have applied this rule. Okay, so for applying this rule, this is the only criteria. You have to check whether this expression is becoming equal to a pure function of x only or not. If it is equal, then simply do integration e to the power integration px dx, which will give you the integrating factor for this problem. Now we have arrived at the last rule of today's video. It says that if 1 by m into del m del y minus del n del x is a function of y only. In the previous rule, it was a function of x only, where we had divided this expression with n. Over here, we are dividing this expression by m, and we are telling that if you get this as a function of y only, then the integrating factor is e to the power minus integration of this function dy. So let us see this problem. See, for this problem also, the first rule of homogeneousness is not valid, because this term is it is a transcendental function log y. So the homogeneous rule will not be valid. You cannot tell that the power of y or power of x you can find out over here. So that rule is not applicable. For the second one, see, it told that for m, take y common, and inside you will have the terms which will be functions of xy, a product of xy. That is also not valid. You take y common, you have log y. So no term of xy is there. So the second rule is also not valid. What about the third rule? Let us not rule out the third rule. See, for the third rule, you have to check del m del y minus del n del x into 1 by n is a function of x only or not. For that, you have to find out del m del y. So for del m del y, it is in the form of u into v. So y into derivative of log y, that is 1 by y, plus log y into derivative of y, that is 1. So what you are getting? Y cancelled out, 1 plus log y. So del m del y is 1 plus log y. What is del n del x? Del n del x, derivative of x is 1 minus no term of x. You are doing with respect to x, that is y is constant. So 1 plus 0, that is 1. So del m del y is obviously not equal to del n del x. So this equation is non-exact. Now let us see whether rule number 3 is applicable or not. Del m del y minus del n del x. So this minus this, what you are getting? Only log y. 1 plus log y minus 1, that is only log y. Now see, if you divide log y, this, by n, as in the previous rule, what is n? X minus log y. If you divide this with n, so it will be log y by x minus log y. Now this term is neither a function of x only nor a function of y only. So third rule is not valid because this is not a function of x only. So let us see if what happens if we divide this by m. Now since this is log y, if you do 1 by m over here, that is log y by, this is m, y log y. So log y gets cancelled out. It is 1 by y, which is a function of y only. So rule number 4 will now be applicable over here. What will be the integrating factor? So over here, since we have got this expression as 1 by y, the integrating factor as per the rule will be e to the power minus of integration 1 by y dy. That is e to the power minus ln y. Now this minus 1 into ln y, that will be e to the power ln y to the power minus 1, that is y to the power minus 1 only, which means 1 by y. So 1 by y is the integrating factor for this problem. You have to multiply 1 by y with upon this ODE and then you have to proceed for the solution. So in today's video, we have seen 4 rules for finding integrating factors. In the coming video, we shall see 2 or 3 more rules for finding integrating factors. If you have liked today's video, then do share this video with your friends, follow my page and subscribe to my channel. Till then, goodbye.